Hi, and welcome to our first honors geometry lesson for Chapter 1, Points and Lines, Lesson 1.1, Points and Lines as Locations. So, one thing that you'll learn about geometry compared to algebra is geometry is very definition heavy. So I've done my best to break down some of the key pieces into understandable bullet points and simple definitions rather than some of the more complex mathematical definitions that they like to use. So, starting with the first thing we're going to look at is right here. It didn't print very well, so my apologies, but that is Euclidean synthetic geometry. So Euclidean, Euclidean, named after Euclid. And Euclidean geometry, you don't really need to understand fully what it means, other than it's the most common type of geometry that we basically exist in. It's the standard geometry that we typically use. Now, what you want to know is there are non-Euclidean geometries, meaning they're other types, but the geometry, the shapes that you've already been working with in your life, those are in Euclidean geometry. So the description of a point, or our definition of a point in Euclidean geometry, is that it's an exact location. So we define a point as an exact location, but what does that really mean? So the 3 bullet points here, a point is represented as a small dot. So we represent it as a dot when we draw it. But a point really has no length, no width, or no thickness. And the way that we name any point in geometry is simply naming it with a capital letter. Then we have a line. So our description of a line is that a line is a set of points extending in both directions, containing the shortest path between any 2 points on it. So a line is basically the shortest path between any 2 points, and it extends forever in those directions. So breaking it down to these bullet points, it's connecting 2 points along the shortest path. A line has no thickness and an infinite length, meaning it goes on forever. We cannot measure its length. Then it is named using any 2 of the points on it. So we could name a line, let's say it's written as line AB, we could name it AB or BA. So if we look down here, for example, let's say using this line, we have B, we have O, and we have A. Now what you want to know is when you name a line, we need to, and apologies for this terrible drawing, but you draw a segment with 2 arrows on the end, and then if we're naming it line AB, underneath that you would write A and B. So our symbol is a line segment and then arrows on the ends. So with lines, again, no thickness. So we draw them and it looks like the thickness of whatever your pencil is. So a line, then we put arrows on the end. Terrible arrows, I know. And we could have also named this line down here instead of AB. O is also on it. So naming that OB. Terrible B, I know. But OB would be the same line. So any 2 points along the line, we can name it using those points. Order does not matter. Then, through any 2 points, there is exactly one line. So it doesn't matter where these 2 points are located. Any 2 points can always be connected with exactly one line. And later, we'll also get into a definition of a plane. Through any 3 points, we always have a plane in geometry. So through any 2 points, we get a line, and as you'll see in the next couple lessons, through any 3 points, we get a plane. And then we have what are called coordinates. So we've defined a point, defined a line, and to understand the idea of points and lines being locations in geometry, we use coordinates. So every distance from the 0 point can be labeled with exactly one number or its coordinate. So in examples here, if you have a number line, and if this is where 0 is, so point O is at the 0, so its coordinate would be 0. Point A is 3 away, so its coordinate would be 3. Point B is at -2, so its coordinate would be in -2. So a coordinate is a number that we assign to a point, and it basically describes its location. So then we look at that idea of coordinates to get our definition of distance between 2 points. So any 2 points, any point can be assigned a coordinate, and any 2 coordinates or 2 points can go on a coordinatized line. So what we call a number line is a coordinatized line. So the way that we figure out the distance between 2 points. The distance between 2 points on a coordinatized line is the absolute value of the difference of their coordinates. So in symbols, the distance between 2 points with coordinates A and B is A minus B inside the absolute value symbol. So if we wanted to, looking at this example, AB here, so for example 1, find AB on the number line above. So for AB on the number line above, we would do A minus B and the absolute value of that. So A is at 3, A equals 3, B is at -2, so 3 minus a -2, subtracting a negative, same thing as addition. So that is 3 plus 2. 3 plus 2 is 5. Absolute value of 5 is also 5, so we're good to go. That distance would be 5. If you're answering for distance, so the definition of distance, there's a reason we use the absolute value. An absolute value always makes the final answer positive. A rule in mathematics is distance, plain distance, cannot be negative. So if you ever get a negative answer, what you probably did was you forgot to apply the absolute value. Now, if you do not recall an absolute value from geometry, or from algebra, I should say, an absolute value is simply how far away from 0 a number is. And that's always a positive value. So the absolute value of 5 is 5. The absolute value of -5 is also 5. So then, if we're looking at example 2 here, find the distance between M and N on the number line below. So M is at a coordinate of -5. 1, 2, 3, 4, 5. And N is at a coordinate of +8. So to set this up, I'm going to do n minus m, so 8 minus -5, and then the absolute value of that. So 8 minus -5 is 8 plus 5, which is 13. In example 3, find the distance between 2 points on a number line with the coordinates of -100 and -300. So I'm going to take my -300 minus my -100, and that's inside the absolute value. So -300, getting 100 back, would be a -200, and then the absolute value of -200 gives us a +200. So our distance would be 200 units. And then example 4. Now, example 4 is a word problem that tries to throw you off a little bit, but if you draw yourself a picture, it's going to probably help you understand it. So as you can see in the bottom right there, as I read through the word problem, I drew myself this picture to help me understand the problem. So we have a circle drawn, and the center point of that circle is at a coordinate -2.7 on a number line. One of the points where the circle intersects the line, or where the circle and line intersect, has a coordinate of 1.4. What is the other point of intersection? So I drew myself a circle, and I simply drew a diameter segment going all the way across through the midpoint. My midpoint I knew was at -2.7. Then to make this into a number line, 1.4 was where that line met the circle. So now it's a coordinatized line or number line. And what I can do is figure out the distance from that 1.4 to my middle of -2.7. So 1.4 minus -2.7 is 4.1. So that tells me that the distance from the middle to any point on the circle is 4.1. So if I'm going in the opposite direction, a -2.7, and this is 1.4, I want to go 4.1 in the other direction. So -2.7 minus 4.1 tells me that other point of intersection is at a -6.8. And again, this can be a negative because it's not distance, it's the coordinate where they meet. Our distance was 4.1, which was a positive. So, for this lesson, the key concepts come back to really understanding that idea of a point and a line. A point just represents a location, and a line is any shortest path connecting those 2 points. So then any point can be labeled as a coordinate by giving it a value. And by doing so, we're basically creating number lines where we can figure out distance, and our simple distance expression is point A minus B, and the square, or not the square root, sorry, the absolute value of that. So it's A minus B and the absolute value of that. And then I believe I skipped over this last point before, but it says when A and B are points, if we write them side by side, so like they did right here in example 1, AB represents the distance between A and B. So this is saying find the distance between points A and B on the number line above, or find the distance between points M and N.